All around us, every single day, there's this hidden world, right? An invisible infrastructure of control and precision that honestly makes our modern lives possible. So today, we're going to shine a light on one of its most critical, yet totally overlooked components. I want you to think of it like a giant circulatory system. But instead of blood, it's pumping the fluids that power our lives. Water, fuel, chemicals, you name it. These networks are literally the arteries of industry, carrying all this essential stuff from point A to point B, just doing their job silently and efficiently. But you gotta wonder, with all that powerful stuff flowing around, something has to be in control, right? So what are the gatekeepers that manage this constant powerful flow? Yep, you guessed it. We're talking about valves. And we're about to zoom in from that massive network to really get a handle on the fundamental job of just a single valve. When you boil it right down, a valve is a pretty simple idea with a profoundly important job. It's basically a mechanical gatekeeper. Its entire purpose is to regulate, direct, or control the flow of a fluid. And hey, when we say fluid, we're not just talking water. This could be gas, liquids, even thick, goopy stuff like slurries. So a valve's job really comes down to four main things. First, you've got flow control. That's your basic on-off switch, right? Then there's pressure regulation, which is kind of like a guardian, making sure the system doesn't get overwhelmed. Shut-off is the big red emergency brake, completely stopping the flow for safety or repairs. And finally, you've got throttling. This is the fine art of getting the flow just right. Not too much, not too little. Okay, but here's the thing. Not all valves are created equal. Not by a long shot. It's less like one all-purpose tool and more like a whole family of specialists, where each one is perfectly designed for a very specific job. First up, we've got the ball valve. This is the sprinter of the family, for sure. It's genius, really. There's a metal ball inside with a hole drilled right through it. Give it a quick 90-degree turn, and bam, you go from wide open to completely sealed. It's fast, simple, and absolutely perfect for quick shutoffs. So the ball valve is all about speed. But what if you need a totally clear path, like zero obstructions? Well, that's a job for the gate valve. This is your slow and steady marathon runner. It's not about speed. It slowly lifts a flat gate completely out of the way, creating a totally straight path for the fluid. And that's crucial when you want to minimize any pressure loss. Now picture this. Those ball and gate valves, they can get huge and super heavy, especially in big pipes. So what do you do when space is tight? You turn to the butterfly valve, the compact space saver. It uses this rotating disc right in the middle of the pipe, kind of like a flap, This super simple design makes it lightweight and way cheaper, which is a huge deal when you're working with massive pipes. Okay, but what if on and off just isn't enough? What if you need total, pinpoint precision? That is where the globe valve shines. It's the true precision specialist. See, the fluid has to take this kind of winding S-shaped path to get through. Yeah, that causes a pressure drop, but, and this is the important part, that's what gives it this incredible ability to fine-tune and throttle the flow. When precision is everything, this is your valve. So, as you can probably see, there's no single best valve. It's always a trade-off. You're constantly balancing the need for speed versus precision, or maybe a low price tag versus low pressure drop. The real skill is picking the right specialist for the job. And that brings us to what I like to call the engineer's gauntlet. Because choosing a valve, it's not just picking something from a catalog. It's a really high-stakes decision-making process. An engineer has to run through this whole mental checklist. They're thinking, okay, what's the pressure? What's the temperature? And a huge one is what's actually flowing through this thing. Is it just water or is it a super corrosive gas? Every single one of these factors is critical because messing up even one of them can lead to, well, let's just say a catastrophic failure. And if you want to see just how high the stakes are, just look at this corrosion chart. Let's say you're dealing with moist chlorine gas, incredibly corrosive stuff. You can see right here, carbon steel, stainless steel, even the fancy metals, they all get a big fat D, not recommended. Choosing the wrong material here isn't just a mistake, it's a disaster waiting to happen. Seriously. So, the engineer has navigated the gauntlet and picked the perfect valve. But how do we know it's going to work? How do we know it won't fail under pressure? Well, it has to pass one last ultimate test. And that's where industry standards come in. You've got organizations like the American Petroleum Institute, API for short, and they literally write the rule book. A standard like API 598 is a huge deal. It spells out exactly how a valve has to be tested to make sure it's safe and reliable. Think of this whole process like a super intense physical exam for the valve. They do a shell test, basically pressurizing the body to make sure it's not going to crack. Then there's the backseat test. That checks for any leaks around the handle. And of course, the closure test. They have to prove that when you shut it, it is completely shut. No leaks. Every single potential weak spot gets checked. Okay, so we've gone from these huge pipe networks all the way down to the nitty-gritty details of testing standards. Let's take a step back and ask the big question. Why does any of this really matter? The source material we're looking at really puts it perfectly. It says this decision directly impacts the performance, safety, and profitability of the facility. And that's the bottom line. The right valve just works for years. The wrong one? That can mean shutdowns, accidents, and a ton of lost money. They really are these unsung heroes, right? The clean water coming out of your faucet, the gas in your car, the power that keeps the lights on. Every single one of those things depends on these little gatekeepers doing their job silently and reliably. They are the gatekeepers of our industrial world, this incredible technology that's been perfected over decades. But as our industries get smarter, more connected, more automated, it leaves us with one last, pretty exciting question to think about. What happens when these gatekeepers start to think for themselves?